All right, we're off to a good start here. So, the problem gives you a list of marbles, and the cardinality of the sample space would just be the total number of marbles. So let's see, we have 2 reds, 2 greens, so that's 4, 1 pink, 5, 8, yeah, 9, 10. So I'm counting a total of 10 marbles. I'm guessing that's where this number's coming from right here. So now, if you're going to do this version of the formula, because you do have this option, you can do the probability of A given B is equal to the probability of A and B occurring divided by the probability of B. Personally, I think it's way easier just to do that version, but if you want to do the way you did it, let's do it. I think your issue is you oversimplified it. The probability of A and B is saying, what's the probability of her getting all the red marbles and getting a fluorescent pink one? That means you have to do the old counting problems like you did in the past. So therefore, she's pulling 3 marbles out of the bag. So therefore, there's 10 marbles, and she has to choose 3 of them. That's the denominator of this part right here. So now, the numerator means take care of your condition first. All right, so first thing we'll do is she'll get the pink one. Out of the 1 pink, she's going to get the 1 pink. And then for the red marbles, there's 2 reds. So out of the 2 reds, we're going to choose both of those. So therefore, you can see the numerator here is going to turn out to be 1 over whatever 10 combinations 3 is. I'm going to do that in my little calculator I have off to the side here real fast. That's 120. So my numerator is 1 out of 120. Now, for the denominator, that's where we're going to do the probability of B. So down here, we're going to say, what's the probability? This would be like asking the question of what's the probability of her just getting the pink one? Now, what that means is you're still picking 3 marbles out of the bag. So therefore, when you do this probability, the denominator would still be 10 combinations 3. But now the numerator, the condition, we don't also have to meet the condition of A. The numerator is just going to say, okay, we take care of your condition first. She's going to get the pink. So 1 combinations 1. That's the number of ways getting the pink. Now, we still have to fill in the other 2 marbles, but we can do that with any marbles. It doesn't have to be the red ones. So therefore, out of the 9 marbles, we just need to choose any 2 of those. So now, over here, I'll move this equal sign down here. So now, the denominator is going to become 9 combinations 2, and that is 36 over 10 combinations 3. That's still 120. So you can see this gives us the answer of 1 out of 36. And I really hope that that's the right answer. So that, to me, is coming out to be 0.0277 repeating. So now let's take a quick peek. Let's see what they're saying. 1 out of 3. Oh, they didn't even round it. It's just 1 out of 36. So there you go. So you can see, I wanted to take you through the whole problem the way you were doing it because I want you to see the logic. I want you to understand when you do this, it's not becoming a simpler problem. In fact, well, you're still counting the problem the old way you used to in in the early parts of chapter 6 or late parts of chapter 6. You still have to do the full counting like you used to. Now, when you do the conditional probability, you also have the option of saying, can I just do this? What's the probability of her getting, like you wrote up here, all the reds, given that she already has the pink one? So that means the pink one is in her hand. So therefore, now we're not pulling 3 additional marbles out of the bag. There's only 2 left. So there's 9 marbles left in the bag because she already has the pink one in her hand. So then we're going to choose 2 out. Now, for the things that'll make us win the game, the things that'll satisfy this, getting all the reds, there are 2 reds in the bag. We need to choose all 2 of those, and we're done, because that will now give her 3 marbles. Since this here represents the 2 reds, and she already has the pink, she now has 3. And you will notice this is going to leave us with the same 1 over 36 that we had right there. So the idea here is sometimes in this formula it's easier to count what you were trying to count. Sometimes it's easier to count the given probability, the conditional part, and you just have to decide which one's easier. Hope that helps.